this. All right, so we're basically now going to be looking at questions which are when you factor them, you get two of the exact same binomials. So remember, this can be rewritten as a plus b times a plus b. And the second one can be rewritten as a minus b times a minus b. And of course, this is going to stop right when I need it. Okay, so this is kind of like saying a plus b times a plus b. And this is like saying a minus b times a minus b. So if you're wondering, well, how do I know when I'm going to factor something that's going to get two of the exact same binomials? Here are two examples, and we're going to look at the patterns. So they're called perfect square trinomials because you're going to notice that the first term is a perfect square and the last term is a perfect square. And when you see a question, and what is a perfect square, by the way? A perfect square is a number where when you take the square root, you get a whole number. So 4, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. Those are all perfect squares. So if you recognize that the first number is a perfect square and the second number is a perfect square, it makes the factoring a little bit easier. So what I'm going to do to factor this is instead of going through all of my different options, I am actually going to take the square root of these numbers and try those first. So for example, I know the factors of 4 are 1 and 4 and 2 and 2, but I'm just going to take the square root of 4, which is a 2, and I'm fairly certain the answer is going to be a 2 and a 2. I'm going to say it doesn't work all the time. There are going to be some questions where this doesn't work, but for the most part, you will be successful. I take the square root of 25, and I'm going to get a 5 and a 5. And then I'm going to do the double smiley, so you can go ahead and try it yourself. This is going to give me 10x. This is going to give me 10x again. And I can add both of these to get 20x. So I'm going to put a plus sign here and a plus sign here. So really, is this any different from complex trinomials? No, it's not. The only thing is when you notice that this is a perfect square and a perfect square, it helps you reduce the number of options you want to try. Just take the square root of it and try it, and then hopefully it will work out. You can rewrite this if you want. You don't have to. You won't get marks off if you don't, but if you wanted to, you could rewrite it. So it's 2x plus 5 and the entire thing squared. Now, one other thing I want you to notice is sometimes you'll have a perfect square here and here, but then the middle number will not work out. So if you look at the pattern, there's a way for you to check. If you take the square root of 4, it's a 2. If you take the square root of 25, it's a 5. To get the middle number, you basically multiply this times the number 2. So this middle number is going to be 2 times 5 times 2. And that's how you know it's going to be a difference, an answer where you have two of exactly the same thing. Okay, I know it's not coming up. Samira?
So could you also like divide the middle term by 2, and then the answer you get, you square it, and it should be like matched up with the last term, and then you do like x, and then for your answer when you write it, you do like x plus, and then after whatever you just squared, so like whatever you just squared.
Okay, so good questions. Let's see if what we're talking about works. So see the first question, that's a perfect square because I know when you take the square root of 9, it's going to give you a 3. See the last term, it is also a perfect square because I know when I take the square root of 49, it's going to give me a 7. If I multiply 7 times 3 times 2, I should get the middle term. So what's 7 times 3? And what's 21 times 2? 42. So it seems like this is a perfect square trinomial. And when something is a perfect square trinomial, you can be sure that the numbers that you're going to put over here are just going to be the square root of whatever this is. So I'm going to put a 3x here. I'll put a 3x here. I'll put a 7 here. I'll put a 7 here. And because this is a minus sign, I know my answer has to be a minus and a minus. I don't even need to do guess and check. I don't even need to do the double smiley. I'm 100% sure this is correct because all of the numbers worked out. Like this is a perfect square and this is a perfect square. I multiplied these, multiplied by 2, I get the middle term. So this has to be the answer. And if you wanted, you could just rewrite it as 3x minus 7 squared. Now, if the patterns scare you and you're like, I don't really get what's happening, no big deal. Just factor it the complex trinomial way, and you'll still get exactly the same answer. Narmatha? Like in groups and something. Jennifer? Yeah. Oh my gosh. Yes. Thank you, Jennifer. All right. So the last type of factoring we're going to learn for this entire unit, it's actually the last lesson. It's called difference of squares. If you take a look at your sheet, it's the last column and it's when you have 2 terms. So a difference of squares question, as soon as you have only 2 terms, this is what I want you to be thinking of. And there is a pattern, again, that I'm going to show you. When you have a difference of squares question, the factors actually end up being 2 conjugates. And conjugates, remember, are 2 of the exact same terms. One of them has a positive, one of them has a negative. So let's identify when you can use this. Again, you're looking at perfect squares. So see this first question? This is kind of like saying 1x squared minus 36. Here are the things you need to look for. Does this question have 2 terms? Yes, it does. So that's the first thing. Are both of the numbers perfect squares? Yes, that's the second thing. And is there a subtraction sign in the middle? Yes. If those 3 conditions have been met, then factoring this is as easy as you take the first term and you take the square root of it. So what's the square root of 1x squared? Just 1x and 1x. You take the last term and you take the square root of it. What's the square root of 36? 6 and 6. And then your signs are just going to be a positive and a negative. So there is no guess and check required. There's no thinking. If those 3 conditions are met, then all you need to do is take the square root of this, take the square root of this, and make one of them a positive, make the other one a negative. Sayed? Yeah, of course. So the 3 conditions are you only have 2 terms. There is a minus sign in the middle. So if there was a plus sign, it would not work. And both of the numbers are perfect squares. So numbers like 1, 4, 9, 16, 25, 36, 49, etc. Yeah.
If you were to put x minus 6, would that matter?
Doesn't matter. And by the way, what are these called? They are called conjugates. So the answers, when you have a difference of squares, always ends up being a conjugate. Samira?
Can you put the minus 9 and like any bracket?
Yeah. All right, let's do question number 2. Let's see if the 3 conditions are met. Do we have 2 terms? Yeah. Is there a minus sign? Yep. And are both the numbers perfect squares? Yep. So we're going to factor this using our conjugate, like our little rule. We take the square root of the first number. What's the square root of the first number?
3x.
Good. So it's going to be 3x and 3x. We take the square root of the last number, which is going to be 4 and 4. And then you can put a plus or a minus or a plus. It doesn't matter. That is your final answer. You guys like this type of factoring? We kept the easiest one for the end. It's like you fry your brain with the complex trinomials and then you end off pretty easy. All right, let's try question 3. Angelique? Yeah, and this is the last thing we're learning for factoring. You guys, we run into a little bit of a problem. So let's go over our 3 conditions. Do we have 2 terms? Is there a minus sign? Okay, but are 2 and 18 perfect squares? So look at this question and tell me what we're going to be doing. There is something we can do. Matusha? Greatest common factor? Yeah, we can actually take out a greatest common factor. What is the greatest common factor in this question? Good. So I'm going to factor out a 2, and I'm going to be left with x squared minus 9. And now, are both of the numbers perfect squares? Yeah, because remember the number 1 is a perfect square. So now this is a difference of squares question. What am I going to have in my brackets? Freya? Yep. Yep. X plus 3, x minus 3. All right, question number 4. So let's look at our 3 conditions. We have 2 terms. We have a minus sign. Are 8 and 18 perfect squares though? No. So what do you think we're probably going to have to do in this question? We're probably going to have to take out the greatest common factor. So that should always be like your strategy. If you notice that, don't panic. Like if there's an 8 and 18, it just means you're going to take out the greatest common factor of 2. We'll be left with 4x squared minus 9y squared. Okay, now let's look at what's inside the bracket. Is 4 and 9 perfect squares? Yeah, so now all 3 conditions are met. We can go ahead and try to factor this. So what is the square root of 4x squared? 2x and 2x. What is the square root of 9y squared? And the signs are going to be positive and negative. So if you take a look at question number 5, it looks like a perfect square trinomial. Let's go through our checklist. It has 2 terms, yes. It has a minus sign, and it seems like it has a 1 and a 16. So nothing seems fishy about this question. We should be able to factor it just like how we have been. So let's go ahead and do that. What is the square root of x to the power of 4? Excellent. So if you're thinking of 2 numbers that multiply to give you x4, it's going to be x squared and x squared. Remember your power laws. When you're multiplying, you add the exponents to get the final answer. Square root of 16 is 4 and 4, and I'm going to put a plus and a minus. So why did I put this question as one of the tricky ones? Can anyone see why this is a tricky question? John Hearn? Sure, yep. When there's an exponent of 4, I want you to be on high alert, but there's a reason for why I want you to be on high alert. Why is that, Safir?
Multiply whole numbers, it's going to be like 4 times 4 is 16, but multiply 2 exponents, it's going to add the other exponent, not multiply it. Because 2x multiplied by x squared multiplied by x squared is x to the power of 4.
Okay, good guess. I like both of those answers, but not what I'm thinking of. Majid? You may what? You may forget about the x squared. Yep. Okay, any other answers, Angelique? There we go. We got it. If you take a look at both of these, is the first bracket, can I factor that again? I can't because there's a plus sign, right? I can't factor that. However, look at the second bracket. Can I factor that again? Is this a difference of squares? Does it have 2 terms? Yes. Is there a minus sign? Yes. Is 1 and 4 a perfect square? Yes. So the reason why this question is tricky is because you are actually not done after that first step. You can keep going and you can factor this again. And the general rule is whenever you have an exponent like a 4 or an 8 or anything that's bigger than a 2, be mindful that that question you may be able to factor again. In your practice questions, I did put a bunch of those in there. So what are we going to do for this? We're going to keep the first bracket the same. Why can't I factor the first bracket, by the way? Right? Exactly. It has a plus sign. We can't factor that. That stays as is. The second one, however, 2 numbers, the square root of x squared will be x and x. The square root of 4 is going to be 2 and 2. And then I'm going to put a plus sign and a minus sign. And now the question is complete. All right, for this last question, I am going to use substitution. So I'm going to say let A equal what is inside that bracket, which is x minus y. And then I'm going to go ahead and factor it like that. So it's going to be 9a squared minus 4. Is this a difference of squares question? Yeah, 2 terms, minus sign. Both of them are perfect squares. So what am I going to get as my answers here? Yeah, 3a, 2, 2 plus and minus. And then once you're done factoring, you're going to bring back that x minus y, and then you're going to distribute. So it's going to be 3 bracket x minus y plus 2, and then 3 bracket x minus y minus 2. And we just distribute the 3, so it's going to be 3x minus 3y plus 2, and it's going to be 3x minus 3y minus 2 as our final answer.